Okay, what volume will 5 grams of N2O gas occupy at 50 degrees Celsius and 12 atmosphere? So this problem is a classic ideal gas law problem. PV is equal to nRT. We're solving for volume, so we're going to have volume is equal to nRT over P. So this is the equation that we will use in order to find out what the volume is. The first thing we need to do is convert our grams of N2O into moles. So how many moles of N2O is equal to 5 grams of N2O? We take the grams of N2O. We know that for every 1 mole of N2O, we have 44 grams of N2O, which this here is going to give us 0.11 moles of N2O. We know what our ideal gas law constant equals, so it's equal to 0.0821 liters times atmospheres divided by Kelvin per mole. So that's what the ideal law, the ideal gas constant is in this unit. We know what our temperature is. Our temperature is going to equal to 50 degrees Celsius plus 273 Kelvin, which is going to give us 323 K. And we're told what our pressure is. Our pressure is equal to 12 atmospheres. So knowing all that, we can then plug back into the equation. If this is our equation, volume, we have 0.11 moles times R, which is 0.0821, times our temperature, which is 323, divided by our pressure, which is 12 atmosphere. This here gives us an answer of, let's see, the answer here would be equal to 0.24 L liters. So that's what our volume would equal to. Okay, let's see. Let's look at another problem. It says, what is the mass of 250 milliliters of CO2 gas at 25 degrees Celsius and 1 atmosphere? Okay, in this problem here, we have to do it a little bit different. We're still using the ideal gas law, but in this instance, we ask to determine the mass of a substance. So we have PV is equal to nRT, but the only way that we can get mass here is through moles. So we solve this from moles, which is equal to PV over RT. Within solving it for moles, we know that the molecular weight of a substance, or the formula weight of a substance, is equal to the number of grams per mole, which means that N is equal to the grams of a substance over the molecular weight. And if we know that G over the molecular weight is equal to PV over RT, we can solve for the grams by multiplying both sides by the molecular weight. So we have grams is equal to PV over RT. All of this here is times the molecular weight. So, having said that, G is equal to pressure times the volume over the ideal gas law times the temperature times the molecular weight. It's the molecular weight of CO2. Let's write down what we have. The temperature, or our volume, is equal to 250 milliliters. Our temperature is equal to 25 degrees Celsius plus 273, which is 298. Our pressure is equal to 0.350 atmospheres, and our R is equal to 0.0821. So if we put all this stuff back into the equation, we would have 0.250 pressure, that's 350, I'm sorry, 350 times my volume, which is 250 milliliters, times my molecular weight, which is 70, divided by my 0.0821, and time my temperature, which is 298. When I do this calculation, I should get 0.25 grams.